G'day guys. Another controversial issue that is sort of bantered about is that high protein is damaging to the kidneys. Some of these ideas come from the plant-based sort of mafia, as I call them. Obviously, some of these things have trickled into our community to different degrees. And a lot of them is based on either observational studies, skewed studies which are based on people who are sick, who have already had severe renal failure, damage and stuff like that, and no longer can their kidneys function properly. So, and ignoring completely that the diets that these people were on were not high protein diets. They were very poor in protein. They were high in sugar and seed oils for most of their life. There was people with diabetes and all sorts of other chronic diseases. So it's just nonsense. A lot of it's epidemiological. A lot of the actual rat studies, especially the modern rat studies, are just completely and utter garbage, financed by big pharma, financed by big food corporations to sort of promote their agenda. They provide no real truth or no real value because they're loaded with certain substances. In many cases, they are skewed or deficient in certain key nutrients deliberately, because this is how the industry works. I mean, we know with the statin studies, they do multiple studies. They cull the numbers down until they get to a certain group of people where, because of genetics, because of number of factors, they tend to do slightly better on statins in that short period. They never do long-term studies because we know that when you do long-term studies, you actually see increase in cancer and all sorts of other conditions, deleterious conditions. So they sort of focus on that. Today's is pretty much a focus on protein, very important within our community. And let me just share this screen. This is the sort of typical nonsense you get. This is a plant-based, one of those, foodnavigator.com. It's sort of plant-based type of, website. As you can see, plant proteins, development of diversification in plant-based analogs, So it's all this sort of garbage, kibble-based agenda. They go, oh, this is back on the 19th of November 2019, and their emotivo, high protein diets risk irreversible kidney failure, study warns. It's all this sort of epidemiological garbage. Avoiding carbohydrates and substituting them with protein has become a leading dogma for all those who care for their looks and health, which is basically they're pointing the finger to keto and carnivore type people that, while high protein diets are very often recommended to people who suffer from diabetes or who are obese, but they say cutting carbs may save us calories, the calorie in, calorie out, if you cut out the carbs, high protein diets risk the health of our kidneys, according to new studies, with people who suffer from diabetes or who are obese particularly vulnerable. How caring these people are, about these poor people, Anyway, I mean, you got people on fucking dialysis, that's how, what a joke. So these are the three sources, and we'll just look at them. It's just fucking the deplorables, There's, I mean, what a bullshit statement to make. High protein diet is bad for kidney health. Unleashing the taboo, it's something that somebody who is a reporter would write, not a scientist of any value who's trying to find the absolute, what works and what doesn't in that regard. You only have to take a look at, in this issue, they're talking about the first study analyzes dietary data from, this cohort prospective study on patients who are 60 to 80, prior history of myocardial infarction, and in that part, trial on low dose omega-3. Then, this sort of absolute nonsense and dribble, what they mentioned. And they're talking about basically people who are in a disease state. So that's what they're talking about, really. They're not talking about people who are healthy. You just have to look at the sort of details. Let me just go back here. To the end, emerging data across individuals and populations suggest glomerular hyperfiltration association with high protein diets may lead to higher risks of de novo CKD. So now, whereas the person with healthy, intact kidneys may not be affected by this harmful impact of high protein diets. Well, at least the study admits that. And this other question of that, basically what they're talking about, emerging data, which is associated. This is not clinical. This is not causal. This is just an association study. They're looking at association studies. That's basically what they're looking at. So basically that's just bonkers. Then the next one here is looking at, people basically with kidney failure who have had basically an MIA, heart attack and all that sort of stuff. And here they're even talking about whether the source is from animal or pretty much they're saying we investigated the extent of total animal and plant protein as risk for acceleration of function decline in older, stable, post-MI patients. In many cases, a lot of these people, to get to the stage where they're having really severe sort of stuff, they say high protein intake was significantly associated, which basically means it's just another association with more rapid kidney function decline in these people. But what are these people on? These people are on a mixed diet. That's what they're on, a mixed diet. Very important. So what are they doing? They're engaging the Randall cycle. They're engaging all these growth factors. So does it surprise anyone? They're very sick. Just garbage. And then the last one is basically another epidemiological, basically bullshit study, and food frequency questionnaires, which we know that they are so unreliable and just garbage. So basically these plant-based morons basically gave us 3 studies, which is sort of a review type thing, which is just an opinion piece. Then basically general, food frequency questionnaire based, another food frequency questionnaire based. So you can actually see here, that's all they are. Food frequency questionnaires and reviews of associational stuff. It's basically bonkers. It's garbage. It's basically people on standard diets, and we know how piss poor recall is by people. And most people that are eating normal foods will basically downplay, because their healthy users are biased. So people are generally they will basically make themselves look healthier to the actual to the researchers, and so talk about the sort of foods which the researchers want to hear are the healthy foods, because people have been indoctrinated, so they want to basically show themselves as being and then you've got the other people who don't give a shit, who probably smoke and drink and whatever else and eat just junk junk food and all that. And obviously they're eating garbage, and they'll probably recall because they're heavy hamburgers and all that with seed oils and sugar and whatever else. But the focus will always be on the not on the bun, not on the seed oils, not on the chips, not on the actual sodas, the sugary sodas. No, it'll always be on the small amount of meat that's in the that whole group of components of junk food that they will have consumed. That's probably the only healthiest part. Unfortunately, that will get bagged. As per usual, we know how they operate. We know how they're thinking, their own inbuilt biases. They're not looking at trying to determine, causal relationships. These are associational from food frequency questionnaires. Basically, it's just junk. It's observational junk at its best. That's all it bloody is. So that's the sort of stuff we get continuously thrown at us. Now, when we actually look at kidney disease, we're actually looking at kidneys basically reducing in size, atrophying. When they get damaged, they start atrophying. They start failing. They can't fix themselves. They can't repair themselves. They start, creating a lot of cysts and stuff like that. They look pretty bad and miserable, So they do suffer. And they actually, these guys at least, they focus on some of the sort of, blocked kidney arteries, obviously the fatty deposits. That's a relationship. We know how that happens. Fats turn up there with for repair purposes, guilty via association as the fireman turning up at the scene of the crime, so to speak. Then blood clots, blocked urinary tract can be an issue with leading to pressure and damage to the nephrons. Kidney stones, they can also cause blockages and issues as well. Yes, get on that kibble with high oxalates. That'll do it for you, And then, sort of long-lasting kidney disease, which they talk about but don't really go into. Some of the actual sites do talk about some of the issues that are, that are driving this sort of stuff, sugars and all the other crappy stuff. Some, at least the US Kidney Association is starting to point, some people are starting to point the finger at sugar, which is about time. We've seen some of that information out there. But the problem is with a lot of the actual recent, modern studies, obviously we can't do research on humans, because it's illegal to experiment on humans. So, but we can do on mammals, on other mammals, because generally speaking, fatty acid, the way fats are metabolized between different animals can be slightly different. When it comes to glucose, fructose, and protein, they very much, all mammals metabolize protein in a very similar way and utilize protein in a very similar way. They create urea. They basically create, different byproducts, very similar in all animals. So that's not a problem. You can actually research from one animal to another when it comes to protein, generally speaking. The same thing with glucose, generally speaking, and the same thing with fructose. We know, there's sort of fish in the Amazon that tend to basically, come up seasonally and eat fruit and actually, induce fatness, because fructose will get converted in the liver to fat and get stored, and they will fatten up and then go dive deep. We know that bears do the same thing. They'll sit there and just gorge themselves on a lot of fruit at the end of just before in the fall, the end of the summer. So this is well recorded. We know quite well. The thing that we have, all the recent studies that focus is they are very highly confounded, even the ones that are actually in animals, because they incorporate a lot of deleterious things, like a lot of sugars, refined sugars. They incorporate a lot of basically things like seed oils. So they're incorporating a lot of substances, let alone the rats are not like, normal rats. They're modified rats, or they're basically rats which have got some genetics altered and stuff like that. The modern stuff is really hard to work out. What are the drivers? And this is why I usually say, with a lot of people that actually are utilizing a lot of these rat studies and all that, and I actually push back on them and say, well, hold on, those lipids, first of all, there's poor, conversion rates when it comes to linoleic acid to arachidonic acid and a number of other things. So I usually say to people, well, we can't really use those, and they're highly confounded. And, and I always point to that specific study where they were just giving just meat, bacon, and it was protective, even to a rat that was basically deliberately, they were inducing cancer to it. So it's rare to find in the literature studies which actually have real food. The problem, most studies out there are really designed deliberately in one way or another to, put things which really no animal in nature would consume, or even a human would not consume things in that sort of way. We would not consume just crap made in a lab in a certain, we eat a mix of foods as well. So you can't really, that sort of research is really just dodgy as dog shit. So the problem is the only research that we're left with is old research. We have to go all the way back to look at old research to understand, to really get an understanding of, some of the relationships of these things, certain dietary macros, and also an understanding of and try to find good studies that actually take into consideration, total nutritional requirements of the animal. Because otherwise, is it the micronutrient deficiencies that are causing the problem, or the protein? And a lot of the actual modern studies, when they look at they do these so-called mechanistic studies. When you look at the rats, the nutrient content, whenever I've been able to access the actual information, they're very piss poor. So they've got major deficiencies. So is it the deficiencies? Is it the protein? Is it the fats, the toxic fats, the refined sugars, and combination, all these sort of things causing the damage? And it usually is something like that anyway, because we see it in our general community that it's basically the pathology is driven by this multifactorial assault on the body, bad fats, bad sugars, micronutrient deficiencies. It's other environmental exposures. It's a combination of things, circadian rhythms and everything else under the sun, that are basically a lot of causal. The key ones are the foods, and then there are all these other secondary things. And the problem is we don't account that. I've always said to you guys that micronutrients play a critical role as a foundation because they play a critical role as cofactors for a lot of enzymatic and protein, processes in the body. So it's critical that, that we understand that, and we've got that in our head when we look at research, so we can basically spot the dodgy research and say, oh, hold on, there are all these factors, they could be confounders. So that's why I've gone back to this following study. I'll just pop it up and I will share this. Okay. This is a really old study, and they received this publication August 27th, 1926. So it's the effects on the kidney of the long continued administration of diet containing an excess of certain food elements. 1, excess of protein and cysteine. So the researchers T. Addis, T. Addis and Etten M. McKay and Lewis Lockhart McKay. So we've got 3 researchers from the Department of Medicine of Stanford University Medical School in San Francisco. So these guys were basically looking at that. Now, they had actually already looked at a number of studies and actually saw that they were deficient in some ways. They weren't well controlled. They weren't well designed. There were some weaknesses in those underlying studies. And so they took really a lot of precautions in the way they designed their study, because this is an experimental study. We're trying to demonstrate mechanisms, and they were very careful in basically trying to get as much good, solid detail in the way they designed to cover all bases, so they could actually then look at that one single factor, protein, and the other one, so they have a control, one on a higher diet of cysteine and one on a higher diet of basically protein, which is basically casein based. And that's what they're actually testing to see. And we're talking about very high doses, much higher than normally any human would consume. So this would tell us that basically what would happen to an animal that was basically not, getting the right sort of nutrients in. So they weren't basically nutrient deficient in any way. They just were basically pushing up the protein component. Obviously, when you push up the protein component, both fat and sugar will come down. And it ends up being a sort of a high protein, low carb, low type fat type diet sort of combination. But anyway, we'll go through it and we'll get into the details. Remember, the important thing is rats, unlike us, don't require as much in terms of in terms of fat as energy to the same level that we require. So there are some differences there in physiology, but here we're assessing kidneys, and that's the importance. When it comes to kidneys, we all originated from rodent type creatures, all mammals on this planet. So their general kidney function, urea, the blood pressure systems and all that are very similar. So in that regard, we can be confident that, any of these results in healthy rats to healthy humans be quite applicable. Anyway, let's get started. During the last few years, several investigators, let me just zoom in slightly, just so it's much clearer for you guys. Okay. So So during the last few years, several investigators have made an experimental study of the effects on growth, nutrition of the administration of a relatively excess of certain food elements. So they're talking about others that have researched different sort of food combinations to see what sort of results they get under uncontrolled conditions, of course. Such experiments have been made on a vast scale over long periods of time. So they're actually pointing out that a lot of the previous studies were done in a very much uncontrolled conditions. So it was more in some regards as observational. That's what they mean by so, which is, we know how piss poor they are. In Arctic regions, for as long as man has lived there, for so long has he had to exist on a diet which contains a high concentration of protein and a minimal amount of carbohydrates, while in certain tropical regions, his food for an unknown number of generations has contained a relatively small amount of protein. Now, that's not exactly true, but that was the understanding that these people had. Inuit consumed shitloads. People in the tropics, they're eating fruit and stuff like that. We know there was no refrigeration back then to store, so it was seasonal. You had 2 seasons in the tropics. That's about it. The rest of the time, you're basically on animals, whether you like it or not, animal products. So that's the reality. And honey is not going to get you very far. Let's put it, because that's seasonal as well. So that's a bit nonsense. Now, obviously, in the more recent times, we know that basically a lot of the people in Southeast Asia, parts of China and all that, yes, consume far more carbohydrates in those periods, but also they were much shorter, not enough protein. You'd eat protein to build bodies, large bodies. That's why Europeans are much taller and larger. Over multiple generations, have consumed more animal products and, high quality protein, simple as that. So, and when we look at those populations, they don't live, you don't see longevity amongst those populations. So let's just put that out as well. You only see it amongst meat-eating populations, whether in Europe or whether in places like Okinawa and stuff like that, which is a very different sort of situation completely. Anyway, let's move on. Opinions have been expressed as to the influence of such differences in the diet on the incidence of Bright's disease and atherosclerosis, and these views they've seen to have little basis in actual observed fact and are largely responsible for the present interest in the effects of high protein diets on kidneys. So basically they say they're observational, and basically they tell us fuck all, in a sense. But the experimental work, which has been reported, has left the question undecided, for while some investigators find that pathological effects are produced in the kidney by diets high in protein, others observe enlargement without any abnormality, while still others fail to see that any effect at all is produced. So they're basically just pointing out the studies that up until that time that have looked at high protein diets basically have come up with mixed results. Not surprising, they're observational in nature, so they're not clinical, and so they basically will have a mixed bag. There are going to be confounding variables that haven't been correctly measured or controlled for. So that doesn't surprise me. It is evident that further data are needed for the solution of the problem, and in this paper we give the results obtained with a diet which contained an excess of protein. We have also carried out experiments in which cysteine was given in excess, because it has been suggested that renal lesions which some have found to follow an excess of protein are due to certain amino acids, of which cysteine is one, and because some evidence has been presented to show that cysteine alone may damage the kidneys. Now, cysteine is definitely high in a number of animal foods, and also in particular in the connective tissue, in bone broth, in collagen and stuff like that. You will find much higher levels of so that sort of view of cysteine is again observational and comes from a bias back then that maybe this sort of collagen type material could be a problem, because it has connective tissue as like a it's like a fibrous type thing, and so they're seeing lesions, and so it's like we're seeing this LDL there, and it's they're seeing lesions, and they're sort of extrapolating from that. Oh, it may be this material coming from this specific amino that's doing it. There's no causal link or any proof. It's just basically speculation back then, So you can see how this sort of behavior in research hasn't really changed in well over 100 years. So it's still, unfortunately, this sort of behavior out there that a lot of researchers still make pronouncements. It's their ego. They want to basically, oh, I found something, a golden nugget. Please put me on a pedestal. It's that sort of, which is the problem. That's why we have to be very careful with research. It has to be, really well conducted, and at the same time be replicatable. That's the important thing, replication. And all we have to find is, remember what we've said in science, you only have to find a one. It's like one paradox, a guy eating 25 eggs a day, or, you don't need another thing, just one is enough to show that, a relationship between one in terms of the Bradford Hill criteria. The more you increase something, the worse it gets. You don't find that, you basically have completely failed to show true causal inference. So keep that in mind. Bradford Hill was quite clear, and everybody quotes him but misquotes him. And one of his key points was that it's dose dependent. The higher, the worse it gets. When you reduce it, the better it gets. So, if you can't demonstrate these sort of things, then you're basically talking shit. We have to be very careful, because a lot of people speculate, but they can't basically back up their speculations with real solid data, and data that actually shows dose dependent and strong statistical inference. Anyway, let's move on. To obtain clear and unambiguous results in experiments of this nature, certain prerequisites must be met. So these guys are saying, we're going to fucking do the best study we can do, based on the current, and we're not going to in any way compromise our integrity. We're going to basically focus on detail and putting it together in the best way. First, the period of observation must be extended to cover a considerable part of the total lifespan of the subject of experiment. Very rare to be done nowadays. Nowadays, we do these short-term experiments for a couple of, for a very short amount of time. Why? Because researchers don't want to they just want to publish. It's all about, oh, let me get that little award. I've put out a study. Oh, somebody's actually noticed it. We know what happens. Unfortunately, the field has been quite severely corrupted in that regard. Anyway, before this work was commenced, we had found that every pronounced excess of various food elements had no pathological effects on kidneys of the rats over a period of 54 days, a time which corresponds to nearly 4.5 years in the life of a man. So they basically we're looking at that side. We continue to use white rats in these experiments, but we have extended the period of observation to a year. So these guys decided we're not going to do it for 54 days or, like they do nowadays for a couple of weeks or one month or whatever. Why? Because they're not interested in long-term observations. So they said they're going to extend this observation period for a year, which is great. Which according to Donaldson's estimate is equivalent to 30 years of a man's life. So remember, the metabolic rate of rats is much higher than ours, and so they age much quicker. So, and they die earlier. So 1 year is equivalent to 30 years for a human. That's nearly a generation. 33 years is a generation. So that's pretty crash hot. That's the sort of research we want, long-term type research. In the second place, it is important that the addition of excess elements shall be the only difference between the control and experimental animals. So that is fucking important. That statement there, that the second place in the importance, the addition of excess elements shall be the only difference between the control and the experimental animal. So everything else will be covered. That means they'll get the same vitamins and minerals, they'll get the same energy levels, all the other stuff, the elements. The only difference will be the protein quantity. Everything else will be identical. So this is like what you would do in a clinical setting where you would control one factor. Everything identical, one factor. Very important. This is why I like this study. You can go back to old studies and you can see really good quality and thinking and saying, we need to tick off all the boxes and make sure we've covered everything to be identical. And we're just going to focus, truly on this. No confounding here. Like all these other observations. Oh, fill in this questionnaire and just tell us your nonsense. And then we will statistically adjust it for you and come up with results that we think are credible. Yes, let's say we'll manipulate the data to suit our narrative. That's what they're actually really saying. Anyway, so we've covered that part. Let's move on. Our control and experimental groups were made as nearly identical as possible. That's good. They really worked hard to, keep things as ultra similar, as if you're basically dealing with, let's say, because these are, as if you had twins and, you controlled everything, the animal being similar, the foods that that the animals ate were all similar, bar one element that they are actually researching. This is really good experimental work, and that's what we want. Not observational crap. We want to observe real experimental work, not basically this sort of confounded free living nonsense. Anyway, at the beginning, they were all exactly 30 days old, same age, no difference. And of course, were the same sex. Obviously, you definitely want them the same. And Dr. Slonica colony, so this must be a guy back then that had a colony that provided rats to basically these researchers, which had been reared in the laboratory through many generations on a constant diet under very uniform external conditions. So this guy that provides these researchers with rats basically makes sure that they are actually grown in similar conditions, uniform, same food, same everything. So this is really controlled, really detailed. Doesn't really happen as much nowadays. They order, they send you the rats, and all that. So the rats can be quite different amongst themselves. They can basically, these guys actually sat down and made sure that the rats that grew up to 30 days were on the same diet. They lived exactly the same conditions. You know, they really made sure there were no variations, or they tried to minimize the confounders down to, you know, really, I love this. This is the sort of research that we need to bring back, not the nonsense that we do nowadays. Anyway, in each control and experimental group, the individuals were so chosen that the range of variations in body weight was nearly the same, while the average weight approximated the normal average stock weight at that age. So basically, they made sure that they were at the same weight that you would find with the stock that actually is being produced. So really, really well controlled for all these sort of things, all these factors. Throughout the experimental period, the animals were kept side by side in the same constant temperature room, into which no light came which had not first passed through the glass. They were all housed in cages of the Slonica type 1, fed in the same way, handled for weight at the same time. But the most essential conditions of all is that the control and experimental diets shall both be amply adequate for growth and maintenance, as closely comparable as it's possible, except for the experimental variable. So everything else, they've made sure that these rats were grown in the same conditions, in the same similar pens, you know, to achieve similar weights, all the factors, you know, to grow to similar levels at that by 30 days. You know, they've really, you know, gone out of their way to really control everything from birth to the beginning of the experiment and onwards for the year. You know, so that's the sort of stuff we really need to bring back. It is, of course, impossible to add an excess protein to the control diet without diminishing to an appropriate degree some of the other constituents, and there is here the danger that the concentration of one or another essential element may be lowered, that the high protein diet becomes defective. So they do acknowledge also that, you know, when you're changing, you know, one element, you're still going to end up with slightly, you know, the diet's going to be slightly altered. You know, they realize that. I mean, that this is going to happen. They're not happy with it, but at the end of the day, it's, you know, one group is going to end up on the high protein diet being slightly more low carbohydrate, just as a consequence, which is great for us because we're really comparing not, you know, a diet which is with a lot of sugar in it and a lot of other confounders like that. We're actually getting a diet which is basically a standard diet and basically a low carbohydrate, high meat diet, which is perfect for the sort of what we want to learn and get the take home for us. But obviously, you know, they were concerned that, you know, that the other elements like carbohydrates and fats and all that would be slightly altered because of the excess protein in those groups. Understandable. Anyway, let's move on. In that case, any effect produced might be ascribed to the excess protein, although it might really be related to the unsuspected deficiency. We have accordingly taken special pain to make sure that the high protein diet contained the abundance of necessary food factors. So what they're actually saying here, they were concerned that if they actually increase the protein very high, that what may happen is that certain micronutrients deficiencies may exist, and then it may skew the data. That means, you know, if they get any certain effects, they wanted to make sure that they didn't actually end up with these rats that were taking the high protein end up with damage which somebody could actually point and say, well, hold on, these were they were deficient in micronutrients. That's what's causing not the high protein, other people could argue. So they wanted to exclude that altogether. They wanted to basically eliminate that potential. They wanted to basically make sure the control rats and the experimental rats that were basically being induced to consume a high protein diet ended up with exactly the same intake of micronutrients. So vitamins and minerals and stuff like that. That's what they're talking about, these other food factors that they basically covered for those. So they could say, well, that's not the thing. The only difference, the only big difference is these ones are not consuming, they're consuming some of the other, carbohydrates and fats and less protein. And these guys are consuming shitloads of protein. And these are the effects. So they were covering all these sort of things. We'll get to the effects shortly. Anyway, the controlled diet is the basis of all experimental, is given in details in table 1. So that's what they were basically on. So basically the controlled one was corn starch, cooked, dried and powdered, casein powder, lard, cod liver oil for, we want the essential fatty acids there, omega-3s and stuff like that, salt mixture, yeast for B vitamins, and alfalfa dried and powdered. So you've got a bit of fiber there as well and stuff like that, and a few other elements as well. So that's what they were trying to cover. Roughage, obviously that's coming from the alfalfa. You've got salt in there. You've got certain water. And these are the sort of, protein, 17.3%, carbohydrate, 44.8%, fats, 24.7%. Pretty much it's a mixed macro diet. These are the percentages in calories, 15, 40 and 50 in terms of fat. So back then, most of our diets were starchy diets. It didn't have a lot of refined sugars and all that. And these are the sort of mixed diets that most people consumed back in the 50s and 60s and stuff like that as well. So before we went into the low fat craze. So let's move on. The high protein diet is given in table 2. It will be noted that the high protein diet is identical with the control diet, except that all the cornstarch and lard has been replaced by casein. So basically they've taken out the lard and they've taken out the, the cornstarch. So you're basically left with essential fatty acids, a bit of fat in there, and basically it's sort of a very high protein. You'll see shortly what I mean. It will contain the same concentration of salt mixture, alfalfa, and 10% of both cod liver oil and dried yeast. So basically they're covering for all, your B vitamins, your essential fatty acids, blah, blah, blah. But there is 69.5% of protein as compared to 17.3 in the control. There was no difficulty in making the cysteine diet almost identical. So with the control diet, it was prepared by mixing 1 gram of cysteine with 99 grams of the control diet. So we knew that our control diet was adequate because during the life and growth curve was better than average, and after death, no constant abnormalities were found in any of the organs or tissue. If now it were found that the high protein cysteine diet could also support growth and maintenance, it might be supposed that this fact would demonstrate that their adequacy so that any organ defect which might occur could not well be thought as possible arising from dietary deficiency. They wanted to cover the deficiencies, remember the micronutrients. This assumption was, of course, often enough been made in feeding experiments, but it is nonetheless unwarranted. So they're talking about, past stuff like that people are talking. So let's look at this diet. This is the high protein diet. So you've got casein. So there you've got your most of your proteins coming from casein, dairy. You've got cod liver, essential fatty acids. You've got basically salt mixture. You've got the yeast and you've got the alfalfa. So really you've just taken out the lard, the long chain fats, and all that, which is fine because remember, these animals still have fat stores, which can be utilized for those long chain fats. Also, cod liver oil is only 30% omega-3s, plus has got some omega-6s, plus has got some long chain fats as well. So there is still an 11% fat in there. There is definitely, when you're looking at the actual carbohydrate component, the diet, it's about 4.5%. And, it's nearly 70% in terms of protein. So as a percentage of calories, it's over 70%. Less than 4% in terms of carbohydrate and 25% in terms of fat, which is basically a ketogenic, more or less a reverse ketogenic diet, a high protein rather than a high fat type thing in a sense. But it's massive. I mean, even somebody on a carnivore diet would only be getting 35% at max, maybe 40% at max of their in terms of protein. I've only heard of one person, a bodybuilder, that was doing about 55% of their macros were coming directly from protein. Majority of people will never get to those levels. I mean, you would have to basically be eating a lot of meat all day and a lot of, powders of protein all day to get to those levels, very high. So we're talking about massive orders here, double. This is really high, guys. You really have to realize we're talking about 70+% of your total calories are coming from protein alone. Nobody eats that as normal human beings. So this is excessively high. Okay. So keep that in mind, that this is excessively high, and all the other bullshit you've heard about protein. Okay, let's move on. For it is always possible that a food which contains an excess of any one element may thereby be rendered so unsuitable that it will not be eaten in sufficient quantities, and in certain organ deficiencies affecting may appear through the body weight remaining uninfluenced. The final exclusion of the food deficiencies as possible factors can be accomplished only by measurements of the food consumption. So these guys went out of their way to measure exactly over a year. Can you imagine over a year measuring exactly what the fucking rats were eating all the time and making sure that they were getting enough? So they went out of their fucking way to basically make sure that, today's a lot of research that's just too fucking lazy to do that sort of stuff, because you basically need to have people continually monitoring this sort of stuff. In our experiments, this was made a relatively simple matter by the construction of food boxes from which the rats were able to remove only the food which they had swallowed. So they had specific to be able to pick up everything and measure it. The food mixtures were so oily that there was no loss of weight by evaporation. So it was only necessary to weigh the boxes after the excess food had been introduced to the termination at a later date from the decrease in weight, how much food had been eaten. The food intake of each group of 6 rats was thus measured every 5 days, and body weight of each. individual rat was noticed every 10 days. From these data, the graphs as the average food consumption and body weights for each experiment has been constructed. Figure 1 and 2 are the results of the first series of experiments, male and female groups, which lived on the diet from 30 days of age to 330 days, and figures 3 and 4 from the second series of males and females that were not killed until they were 360 days old. So that second group was a bit longer. So they had two groups that were putting it through the same thing. So they were doing like two parallel studies in a sense, which doesn't really happen nowadays. Usually you get somebody else to do the other parallel study or a follow-on study or whatever. They were doing two parallel studies just to make sure. These guys were really trying to cover all bases. So they were doing parallel studies to basically say, okay, what's the difference? Is that, if they had seen differences in one group, they could work out there may be other environmental factors. They wanted to exclude everything. These guys, I take my hat off to them, because when you look at the results, very similar here, very similar in this group. You do see the deviation slightly later on in this group, and that's at, where did it start? It's about 280 onwards. So 280 here. So in this group, a bit earlier. From this group. Yeah, that could be a possibility, But interesting. There you got the high protein. The weight's much lower. I'll explain why. While in terms of intake, it slightly did come down. And it's understandable because you're trying to force feed them a large amount of food that will come down slightly. But then it was, after 80 days, it was more or less consistent across. Same thing here, 80 days. This dropped a bit, about, you could say 200 days. But then it was pretty much consistent as well. So this group had a bigger variation, obviously. So it was much harder for this group to feed them enough or get them to eat enough and all that. So that's why we saw a bigger sort of weight loss and intake dropping off a bit more. The one that it was actually at the 360 seemed to be a bit better in that regard. But you can see very tight relationship in terms of intake. The variations are in body weight. This one is pretty tight as well. Just the protein comes down even more towards the end, but still, for most of the period of time, there's no big significant statistical significance. There's just varying off here. Obviously, if you were to go more years and all that, potentially further, but that's understandable. High protein diets are going to create satiety, inevitably are going to lower those sort of factors. Anyway, let's move on. The outstanding feature in these graphs is the failure of the rats on the high protein diet to attain to the weight of the control, with the exception of the female group shown in figures 4. So female groups less, the male groups, but we actually see that in humans as well. Males, when they consume more protein, tend to lose more weight than females. We just see that. It just happens. It's just a reality. We notice that I've seen that in a whole lot of other studies which have to do with mammals. Just as I've always said, we males do much better with a bit more protein compared to the ladies. It's just that reality. And ladies do much better with slightly more fat than protein. It's just that reality. And that's why, you notice this big drop between the two. Here's that group. They lose more. It's all fat mass. And I'll explain it further down. So there's that group. And basically, look, I've only read it once. This is the second time through. So do bear with me in that regard. And it was a long time ago when I read it. So, it's all sort of coming back to me. But anyway, and this is the females. Obviously, it was only really up at 280 when they started veering off from the control. Both groups, but more the actual, but not significant. This isn't, massive, like a massive order. When you look at the males, it's quite significant right from the get-go. It's high protein. You get more loss of adipose tissue. Simple as that. So, yes. Anyway, let us move on. There is, from the beginning of a failure to grow as quickly as the control, and as time goes on, the weight differences widen. Yep, we know that. We know what they're losing, which is important. It'll be further down what this weight failure is all about. The food consumption curve shows that in general, the high protein groups ate slightly more calories per 100 grams. So they're actually eating more and getting slimmer. That goes against the, what we've been told. Oh, if you eat a lot of protein, it will turn into sugar and you will get fucking fat as a 10-ton Tessie. It's all the myths that we get, Anyway, of the body weight and the control, and they therefore took appreciable more vitamins and minerals since their food had a caloric value of only 4 calories per gram, where the control group had a value of 4.8. That's because the fat component, they had more fat. So obviously the calorie went up. But, anyway, we'll move on. That was unfortunately the thinking back then. Rather than the hormonal things, people didn't understand hormones like they do today. Well, still today, even now, they don't fucking understand. They're still in the calories in, calories out mode. But anyway, we'll move on from that sort of thinking. We just want to get the results. How do the kidneys turn out? These are the important things. Anyway. It is therefore certain that the lower body weight of the high protein group was not due to an insufficient supply of any essential food. Exactly. So we can look here, live body weights in GM at 330 days of age. So there's the control. Control put on a bit of weight. The females lost a bit of weight in the control, again, because they were getting slightly more energy to protein, which doesn't surprise me. Females do better with energy rather than protein in comparison to males. So there are those factors. Then we look at the cysteine group. They put on a bit of weight, the males. The females, again, lost a bit. The high protein, what I expected. Females put on more weight. It's more muscle, which is a good thing. And the males put on more weight. It's more muscle. Good thing. So, anyway, some of the rats from which Donald derived this average was born litters. Such animals are generally appreciably heavier than rats of the same age, which have never been pregnant as was the case with our animals. So that's just a general information about the rats that I used. If you're interested, probably not. The body weight of the rats on the high protein diet was defective as compared to our control groups, but it was greater than the standard normal values given by Donaldson. So they're a bit critical of him. The body weight of on the 330th day of age was compared with the Donaldson in table 3. And that's the table here that we're looking at, their rats. Anyway, in comparison with the other guys' research, which they've referred to anyway. There was thus no growth inhibition, only a failure to reach the quite unusual weight of our control and cysteine rats. So they didn't fail to grow. They grew normal, but they grew lean normal, where the other ones grew, but they had a bit more adipose tissue, fat. We had expected to follow the urinary changes without the whole course of experiments, but it was not until more than half of their total duration had elapsed that we succeeded in devising fairly satisfactory methods for a quantitative measure of the changes in the rate of excretion of protein and the formed elements of urine. For the collection of urine, each animal was placed in a small round wire cage set over a glass funnel at the beginning, and at the end of 12-hour periods, the bladder was emptied by making the rats inhale a little ether. So they pumped a bit of ether in there to sort of force them to, piss on cue, so to speak. So initially, they didn't have that set up. They did it later on, and we will look at that shortly. Anyway, the procedure is invariably followed by urination. At the end of the period, the rats was held over a centrifuge tube while the ether was given in the manner clear urine was obtained for microscopic examination. The volume was thus collected, averaged nearly 20% of total amount in 12 hours, and so no serious errors were introduced by calculating from the number of cells counted in the proportion that might have been expected in the whole volume had been sampled. The techniques of counting was recently being described. 3, the method of Shevke and Stanford was used for the determination of protein, but it was found that irregular results were obtained unless the urine was diluted to 5 times its volume with water. So they actually found that you had to dilute it to get proper measurements. So they worked all that out. Since the concentration of protein in rat urine is sometimes quite low, we had to have special tubes with fine gradations constructed. So they actually had to make really their own custom designed in order to capture and to concentrate, So basically these means data was collected, which through negative from the point of view of the detection of renal abnormalities have an interest of their own. So even though we've got negative abnormalities, none there to be seen, the average results at the rate per gram of renal tissue was given in table 4, which is the average of 12-hour rates excretion of urine from series 1 and 2, the 2 groups, expressed as a rate per gm of renal tissue. Okay, the volume in cc's and the other one in protein in milligrams. Okay, white and epithelial cells. So when we're looking at these different groups, white and epithelial cells, Control, you've got slightly higher with the cysteine group and in the males, and much lower in, which is a bit surprising, in the actual high protein group. And in the females, it's sort of the other way around. The cysteine is much lower, the control is much lower, and the higher one is the female group with the high protein. So, you know, okay, a few extra cells there. It shows the difference between females and males when it comes to protein. That's one thing. Then when we saw, and it probably has to do why this sort of effect has probably to do with the sort of the excretion as well. So we can see that basically in terms of volume, nearly double. And in the females, it's not, you know, it's probably about 50% or whatever. It's not even that. You know, it's much less than that. When it comes to protein, it's nearly double, except the cysteine, which is probably about 50%. But you don't notice a big, massive order of difference between the females. So again, there are differences in females and males, the way they handle protein. The number of white cells and epithelial show no significant variations in any of the experiments. So nothing major. We're not talking about dramatic here. The greater the volume of urine from the rats on the high diet is only that might have been anticipated, that they would have a higher excretion. But the high rate of protein excretion in males than in females was unexpected. So they didn't expect to see the sort of differences where males actually excreted more than females. Very interesting. It will be noted that also the average rate of excretion is appreciably high in both males and females in the high protein than in the control or cysteine rats. The average individual rates from all groups are charted in figure 5. So we can see different series and all that. Anyway, we've already covered that, so I'm not gonna. Anyway, where was I? These graphs reveal the fact that the average increase in the rate of protein excretion by the rats on the high protein diet arrives from a temporary marked increase and is not due to a constantly maintained high level of excretion, nor any steadily augmenting rise in the duration of the experiment is extended. On this account, its meaning is uncertain and will probably remain obscure until we learn something of the general significance of the excretion of protein by all rats. So they notice initially, you know, on high proteins, and then sort of they come together. It seems that the body sort of adjusts. That means adjusts and learns to manage these much better. So what's happening? So that's sort of which is to be expected. I mean, when you make dietary changes, your body has to adjust, and that's what they're doing as well. They just don't know the exact reason. Well, they know that what's the main cause of the high protein, but exactly how all these mechanisms are working. And even today, we don't really understand it, guys, really, you know. But our interest is it going to cause us damage or not? That's really what we're interested in, ultimately, and that's what this research is looking at. Red blood cells were often present in considerable numbers in the urine of the control rats. In 78 control, there were 2 in which was microscopic blood lesion, lesser degrees of hematuria recognizable only in microscopic examinations were frequently but quite irregularly observed. In the cysteine group was 4 out of 84. So what's that? So we got 2 out of 78, which is about 2.5% in the control. It's about 4.8%. So it's about nearly double. 3.90, which is about 3.3% in the high protein group. So again, the cysteine group seems to produce a bit more, but who knows? It could be chance. In the cysteine group and in the higher group, the 3 were found in the red blood. It seems likely that at one time or another, red blood cells were present in the urine of every rat under observation. And that's the important thing, every rat basically. The reality is every time we eat certain things and all that, there's going to be slightly excretions for a number of reasons. Metabolic things or metabolism put some stress on the body. Simple as that. So we even notice it with humans. It's nothing. It's only when you got severe, very minor amounts is irrelevant. When you got considerable amounts, that's when you have concerns. Anyway, in the females, they were definitely less often seen. So females seem to just do better, maybe, It's probably why they live longer in all species. Probably manage to deal with metabolic, the consequence of metabolism much better. Lucky them. All through, the total amount of blood excreted was probably somewhat greater in the cysteine and high protein rats than in the control. The difference were certainly slight. They weren't statistically significant, let's put it that way, as I showed quite clearly. And that's the reason why I did those calculations to show that it was basically fuck all. It could be the chance, could be a whole lot of factors, but we'll leave it at that. An occasional hyaline cast was found at one time or another in the urines collected from nearly all of the experiments. So no difference there. Everybody's the same. There were no more frequencies. They were no more frequent in the high protein than in the control or the cysteine group. Exactly. So no difference whatsoever. In the rats, as in man, a small number of casts is constantly being excreted. Exactly. So, and we just have to look at, we humans will always, there'll be some level of oxalate, some level of calcium, some level of whatever, certain types of things that will be excreting. There's always going to be things that are going to be excreted and at play in a sense. So those things don't really concern me because, as long as they're in all groups very similar, which is what we detect even in humans, who cares? It's not, there's no real association. It's just sort of just basically part of metabolism. A lot of these sort of things that get excreted. Where was I? In the rat. And so it is not the presence of casts, but an increase in their numbers, which indicates an abnormality of the kidney. And since we didn't see anything like that, there is no abnormality. Since the concentration and reaction of urine were examined, were favorable to the presentation of casts, we regard our negative findings as a strong evidence against the existence of any active renal lesions of the type meant with Bright's disease. So they didn't see anything there. As I said, some of these conditions are basically metabolically driven, And some people have got genetics as well. So there's a lot of factors. I'm not going to focus on diseases at this stage. We're just focusing on the protein side. So we'll ignore all that. It's just talk. The single instance of positive findings remains to be described. It occurred in a male in the first series of the cysteine diet. Yeah, okay, they found a bit in the cysteine, who cares? Marked increase in the rate of protein excretion and the presence of numerous was noted at the first examination at 258th day of age. At the end of the experiment, the concentration of protein in the urine was over 2% and 51 milligrams were excreted in 12 hours. The number of cars was calculated 82,000 per 12 hours. And these 1% was epithelial, 0.5% waxy, and the remaining was hyaline cast sprinkled over with fat droplets. The number of epithelial cells of and white blood cells was greatly increased and present in greater numbers than the red blood cells. It was estimated that in the 12-hour urine there was 1,240,000 epithelial white blood cells and 330,000 red blood cells. In the human urine, such a sediment is typically of an active degeneration in renal lesions. This rat had grown rapidly up to its 80th day, but had lagged somewhat thereafter. Thought it never fell appreciably beyond the group variations, and in the end weighed only 5 milligrams less than the other rats in the same experiment. So for some reason, look, sometimes animals that live amongst other animals may behave in a certain way and all that. You know, there's competition in trying to get to certain levels and stuff like that, and that could explain that sort of thing, because one of the, you know, it's just the odd one out, so to speak. So it's not a consistent thing, but then it sort of normalized. So, you know, hard to know exactly what to make of it. But that wasn't the high protein; it was the high, you know, on a standard diet with just some added cysteine to it. So it doesn't tell us anything. Still tells us that a mixed macro diet probably isn't the best. Anyway, blood urea concentration on 330th day was 68.2 milligrams per 100 cc, while the average for the rest of the group was 27.5. At the end of the experiment, the animals were anesthetized, and while the heart was still beating, blood was collected from the abdominal aorta. So basically they made sure they kept them alive, extracted some blood directly from the blood concentrations, was determined blood urea concentrations. So these are the urea concentrations. As you can see, cyst group, these are the series 1 and series 2, you know, the two we're talking about parallel. Remember the two parallel groups? So this one in the control was slightly higher. The cysteine was slightly lower. This group was basically, you know, slightly higher. This group was slightly lower. This group was not much different than the others. This group was quite significant. Who knows the reasons exactly, but more protein should increase uric acid in that regard. But it's not an issue. But at the same time, why this group was much, you know, no different, hard to say. So yeah, anyway, we will move on, and well, the females here actually showed even higher. So, and in the cysteine group, the first group series, but with high protein, so uric acid seems to be much higher in females. So interesting. Anyway, it's good to know. So ladies, you want to keep your uric acid under control, keep your sodium up. Anyway, body weight, but these, remember, we're talking about here exceptionally high levels of protein as well. So yeah, this isn't what normally people would eat. Anyway, body weight, less gastrointestinal weight, the length expressed as a percentage of the control group's lengths and the end of the experiment. Okay, so these are weight and lengths and weight and length. So in terms of the males, weight, they were 75% less weight compared to the control. When it came to length, not much, 4% difference, which is fuck all, neither here or there. In the second group, in terms of length, even less difference, but in weight, not as pronounced as the other group, only 82% reduction. And in the control groups of the females, again, 74%. You know, it's just in the series 2 where the women actually had identical. So you can see basically high proteins will basically reduce pretty much your body weight in that regard. And we know what we're losing, fat. It'll become apparent further down. With a single exception mentioned above, the concentrations varied very little within each group. The average was in table 5. Which is up here. The results of the control and cysteine experiments are close to the average. We have compiled from observations on 1-year-old rats on a standard diet, almost identical with the control used in these experiments. The higher levels attained in the high protein experiment is a result of large nitrogen consumption and parallels in similar effects observed in man on a high protein diet. We know that, you know, that's where you're actually getting these higher levels. Now, it is only a transient phenomena for the blood urea quickly falls to the usual levels when food is withheld. So if you fast, everything comes to the same level. We know that. In the males in series 1, it will be noted that the concentration is much lower than the other high protein groups, in which case the urine had been collected just before they were killed and they had consequently taken no food for 12 hours. Okay, so that explains, that's okay. So that lower level there is basically because of the killing time for that group. Okay, so fair enough. On a post-mortem examination, the principal cause of relatively low body weight, this is the important thing that I've been waiting to tell, of the high protein was found to be an absence of fat. So adipose tissue had melted away. That's where the fat loss came from. Well, the high protein diet basically made sure you lost a lot of, I mean, if you're not eating fat, you're going to be burning your own fat. Simple as that. And we know that. Anyway. So when you're on a high protein diet, So when you're on a high protein diet, remember what I said. When you're on it all has to do with what Ben Bickman has been talking about the glucagon, about the insulin to glucagon ratio, really important. So just to cover that point, when you're fasting, it's 0.8. That means insulin is lower than glucagon. Okay? When you eat a steak, and only a steak, basically you're eating carnivore, your insulin to glucagon will go to 1.3. So basically, it's just marginally higher than glucagon. So you'll be in fat burning mode. And that's what these little buggers were, in fat burning mode. So basically, they weren't converting the protein to sugar. They were basically, anything that needed to get converted was turned into fat. So, and fat was being oxidized. So that's what happens, because glucagon is basically much higher than somebody on a mixed diet. So exactly where the others may lose muscle, those high protein ones, they were losing fat, and that's what it shows. And whenever you look at high protein diets, you get the same effects. In particular with men, they lose far more body fat than women. Obviously, women can also lose body fat, but it actually puts their endocrine system into the toilet. So, which isn't something that women enjoy. So they need a bit more fat. Yes, it's just the way you ladies are built. Just accept it. Anyway, so we've worked out where that's gone. This had indeed been evident during life, but it was strikingly demonstrated when the abdominal cavity was opened, and instead of the heavy layers of post-peritoneal fat seen in the control and cysteine rats, only a small shrunken pad was left around the kidneys and elsewhere, and bare muscle could be seen through the peritoneum. So basically, peritoneum, you were just basically seeing muscle. What they saw through the body when they ripped it open, that rat was just muscular, lean, muscular. Very important. So people that will say, oh, if you eat a lot of protein, you will basically get fat, you'll build a shit. Yeah. We've heard it. The reality is when you do experiments, that's not the case. As long as basically insulin is low and the glucagon insulin ratio aren't really out of whack. You only get that on a mixed macro diet. So if you're consuming, like some people, foolishly, bodybuilders will eat rice and honey and whack on the high protein, what they will end up is, yes, they'll create some muscles, but they will basically be like the modern day bodybuilders, fat, muscular, because they're engaging the Randall cycle. Not a good thing. And that's why we have, bodybuilders have always known it. The way you cut is taking out the carbs. Simple as fucking that. But you can ignore that. You can just eat the protein and still become muscular and lean. Why bother with the other stuff? As you said, you can see there wasn't much difference. There's plenty of experiments to show that the old bodybuilders that used to basically do steak and eggs and stuff like that were very muscular and very lean, and they were still able to build very big, strong bodies without carbohydrates. Completely unnecessary. unless you want to fatten up for a period, and then you have to go through an extreme cut to lose that weight, and very unhealthy on the body and the endocrine system. So don't fucking do it. Don't listen to those idiots out there, the cranks and wacko dackos, the pseudo nutcases. Ignore them. They just can't get over their carb addiction. Anyway, whether all the differences in weight of the high protein and control rats were accounted for by failure to store fat is uncertain. It's not a matter of storing fat. It's a matter of basically that, because remember that they still got the concept back then. It's in the 20s, calories in, calories out, the calorie concept. Remember, in the 1930s is when a lot of the good research in Germany happens about the hormonal system. So a lot of this stuff hasn't filtered into the US at the time. So that's why they're making these stupid, well, they're not stupid. They are understandable why they're actually making those sort of pronouncements in that regard, because really they don't have enough knowledge about the hormonal system. Anyway, and that's where they're talking about this study, where they show, is that one there? No. So it's this one about the body weight stuff that we just talked about earlier, which we showed, which covers that point, and we will move down to this sort of part here. The complete post-mortem record shows that no gross abnormalities were found in the control rats, with the exception of 2 instances of lipomatia in the menasteri. So, and then amongst the cystine group rats, there was 1 calculus in the right kidney, so they had a kidney stone, and the other was a chronic bronchopneumonia. So one had pneumonia, one had a kidney stone. Okay, and did I miss? Yep, no, hold on. Described by the ectone, a condition which Donaldson has found to be very commonly present in all old rats. Okay, so some of these conditions are found to be in all old rats. Okay, good to know. So they're very similar. Once you get into old age, some of these conditions do emerge. In the high protein rats, which were kept on the diet for 330 days, there was 1 with middle ear disease and 2 with unilateral hydronephrosis. So that was just a bit of swelling, but nothing else, just swelling of the kidneys in 2, and 1 had a bit of an ear thing in there, and that could be from an infection potentially. So we don't know. We'll find out further down. In the 300, on the females in the series 5 had varying degrees of pneumonia, the wheezy breathing characteristics of the more advanced stages of this condition had been noted shortly before they were killed, and thus lung conditions is probably responsible for the loss of body weight observed during the last 20 days of life in this experiment. So some did have pneumonia and stuff like that, and did have some reduced lung conditions. Anyway, good to know all this sort of stuff. That, like us, rats decline in similar ways. Anyway, on the microscopic examination, no differences could be detected between the kidneys of control, cystine, and high protein groups. And that's the important thing. So when they did microscopic examinations on the kidneys, they saw no differences. Even though there were, 2 there that had, swollen kidneys, they weren't damaged. So it could be from an infection. Who knows? What the cause of that swelling, potentially from a kidney stone. There's a whole lot of factors that can be at play. For instance, there is a bit of fiber in there. Potentially, if you've got genetics where you don't manage oxalates well as an animal or a human, you can be more susceptible than someone else. So that could be another driver. So we don't know. But, the way you can determine is when you look, do they look all healthy? Do they look, not damaged? We know that basically that kidneys, when they get damaged, they atrophy, they become smaller, they shrink, or they get a lot of cysts around them. They didn't see any cysts, they didn't see any atrophy. So, that's a positive thing. Things haven't gone to shit. Anyway, careful measurements might have shown an increase in the size of the proximal convoluted cells and their glomerular in the high protein rats, but it was not apparent at a glance. So they didn't notice at a glance, but they did notice that was much more the actual filtration capacity had actually gone up. So interesting. See, the body can adapt. You eat a higher protein diet, the kidneys will adjust to basically deal with that higher protein diet. They don't become chronically or unhealthy and all that. The only things that basically damage kidneys really, truly damage is the seed oils and the refined sugars, diabetes and stuff like that. Most kidney diseases, people that are on dialysis or whatever, are basically diabetics. And we know what your food is required to basically become diabetic. Don't we, boys and girls? Yes. And so should Salad Boy know that as well, but he ignores it at his own peril. Anyway, so when we look at now the weight of the body minus the gastrointestinal tract and the weight of the liver, heart, kidneys were expressed as grams or milligrams per 100 mm, which I'm not sure. I'll have to go to the actual chart to remember what the bloody thing was. Of length, okay, of 100 millimeters of length, of body length. Okay, that's what it is as a proportion. Okay, from the snout to the anus. Okay, yep, gotcha. The results are given in table 7. I'll read it right through and then we'll go up to the thing because there's also about figure 6. Okay. In order to make the weights observed in different experiments comparable with one another, the control weight have been taken as presenting 100% and the weight in the corresponding cysteine and high protein expressed in proportions. These figures are charted in figure 6. Okay, just keep that in mind. The only significant deviation as determined from the comparison of the actual difference from the control with the probable differences are in the high protein experiments. Okay, so here we notice differences in the organ sizes. The weights of the body as a whole and of the liver are much lower and can be accounted for by the chance, while the kidney weight are considerably higher than the outermost range of accidental variations. So what they're saying is that the body weight is probably down to chance. Now, we're talking about a calorie in, calorie out before they understood the Randall cycle, which Philip Randall developed in 1963, or they understood so you gotta think in those terms. They were experimenting, giving these rats in a very controlled way, large amounts of protein to see what would happen. They did not understand the Randall cycle. They did not understand the things that are related to how these organs work. So if you're basically consuming most of your life very low carbohydrate amount, what's going to happen? Your glycogen storage is going to be slightly less. We know when you increase glycogen store, there's actually even a disease that actually will increase the size of your liver massively. So I would say it's probably because the body became fat adapted in these rats and basically didn't require as higher glycogen store. So I suspect that's one reason why the liver, because free fatty acids don't require to go to the liver. Let's put it that way. I mean, ketones, and it's very hard to put rats into ketosis anyway. They need to be 90% fat, so that's irrelevant. So it's basically they would be using free fatty acids, which don't need to go to the liver. So it's a non-issue. So adipose tissue we just give to the peripheral, to the different tissue around it, and basically provide the energy. That's why there are fats around organs and all that. So even visceral fat does play an important role to provide energy to those organs and systems in close proximity. When it becomes excessive, it can become a problem, and fat droplets in different organs. But small amounts are required to basically as an efficient way to pass in localized energy. So very important. So that's understood in the biochemistry literature. So nowadays, but probably then it was less understood. So even though they thought it was probably chance. No, it wasn't. But anyway, that's how they thought about it, about the liver issue. The kidneys, obviously, were dealing with managing uric acid and stuff like that. So they had to become bigger to be able to filter more of it, clear it out of the system, and balance to the levels that were required. And that's why the kidneys became slightly larger. And were able to deal without actually suffering any deleterious damage. So accounts for the chance while weight. They say accident. Yeah, exactly. Now we'll just go back to, that's the figure 6. And you can see with the different, these are the weights. So you can see here, the length is not much different. The weight is actually dropped of the overall animal, obviously, because you're not basically engaging the Randall cycle, so you are becoming leaner. When it comes to the actual liver, actually the heart became bigger slightly. When you actually give the heart more protein and you give the heart more, it will basically become stronger and loves free fatty acids as well. Same thing with the females, probably just slightly more of the cysteine group. Interesting. And then the kidneys, there was a considerable jump, as you can see. So, and it's dose dependent. Cysteine group, more protein, gets bigger. Same thing with the males, same thing with the females. That doesn't surprise me. If you change your diet, your systems need to adjust, not only, and that's why I say sometimes it can take up to quite a few years for your body to adjust to a much higher protein type diet and stuff like that. So, we saw it with the rats, whole lifetime nearly one generation. So these happen over time, which basically is good, which means that, even into older age, we will be able to manage much higher proteins, much better than others in the community, which basically means that we'll basically be able to fight off sarcopenia, osteoporosis and everything else, because it requires protein, because it is built by protein, all these, both the bones and all that, just because they store minerals, the protein matrix, you still need protein. So it's a good thing to know that we will basically have the capacity to deal with that extra stuff going forward and basically not have to really worry. I can guzzle down my taurine without having any concerns. Anyway, and you can actually see here in graphical representation those differences. Males and the females. Anyway, we've seen that. Now we'll just go to the discussion part. All the precautions observed in these experiments have been specified with, and many have been seen to be an unnecessary attention to detail. No, actually, I'm glad these guys actually really put such detail into their experiment. Back in 1926, with such detail, that's a good thing. You know, fuck. Nowadays, academics, you struggle to get this sort of control or detail in nuancing and understanding that they need to basically make sure that everything is really very similar and there's only one factor that's being changed to really work out what the fuck's going on. So, yeah, unfortunately, we struggle with today's highly confounded nonsense. This is a result of an attentive reading of the literature on the effects of high protein diet. So these guys looked at the other literature, looked at what other people were saying, and said, okay, they could see that there were so many variations in the literature, you know, deficiencies potentially, all these other things. So they said, we're gonna make sure that we cover everything really concrete and really well, and then we'll do our experiment. We'll make sure that they grow in similar conditions up to 30 days. We'll make sure that they, you know, getting all their micronutrients, the essential stuff as well, you know, essential fatty acids, essential amino acids, all this sort of stuff. So they were focused to make sure that these animals were getting those essential things, and then they were just increasing the protein. So really good stuff. I have to say, yes, bravo, very well done. Anyway, let's just move on the rest of the conclusion parts. Anyway, it may be said that there's been probably, results obtained on significant features, various experiments have been fully described. Okay, for it may be said that there would probably be less difficulty in understanding the diversity of the results which have been obtained if all the significant features of the various experimental procedures had been fully described, as it is the lack of detail that has been such that those who have failed to find pathological changes in kidneys have been able to suggest that the lesions which were found may very well have been caused by other factors besides the high concentration of protein in the food. And that's, you know, they're basically saying, you know, these are the guys that didn't find, you know, any massive kidney problems, but they did find some lesions and stuff like that. Stuff that these guys didn't find is probably because it was probably other factors that these other guys didn't actually take into consideration because they didn't control as well how they were doing their studies and making sure that they covered any deficiency or whatever. So indeed, it seems very likely that certain of the high protein diets which have been used have also been defective diets. So they weren't well designed, the previous ones. And still to this day, we still get a lot of poorly designed studies, and don't we know it? I showed you a few earlier ones. Shocking. Yes. We do not think that this is the only reason for the difference in results, but as several investigators have not yet published their work in full, we shall not discuss these possibilities, but shall content ourselves with saying that in so far as damage to kidneys from high protein diets is concerned, we are in agreement with the statement in the preliminary paper of Osborne, Mendel, Park, and Darrow, and with the reports of Drummond, Croden, and Hill, of Reader and Drummond 9, and of Miller 10. These are all the studies that they reference further down, and of Jackson and Riggs 11, to the effects that no deleterious structural effects were produced. So they're referring to all these other studies that actually found no damage. We can only fully confirm that the conclusions of Jackson and Riggs, that a study of the urine and blood given no indication of any renal abnormalities. On the other hand, renal lesions which appear to be degenerative in nature have been found in rabbits kept on a diet containing a moderate excess of protein by Newberg and Polvot and McCollum and Simmons, and by Evans and Risley in rats. So Ewan, Marsh, Clarks, and Curtis 15 have also observed evidence of existence of pathological changes in kidneys of rats whose food, even less than 1% of cysteine, had been added. These results are important because they are positive. Our negative findings are not directly opposed, since we did not attempt to duplicate their conditions, nor our results so general in nature that they can be regarded as final. So basically, they're saying, well, we haven't done what they've done the way they've designed their studies. We've done it, our way, and they've described we've done it, and so they did not find those sort of effects. But they do quite decisively prove that rats can live for a third of their lifespan on a diet very high in casein or with added cysteine and yet escape any damage to their kidneys. This fact leads us to reject the hypothesis that a large consumption of protein is in and by itself necessarily harmful to the kidneys. And that's the important point that they're making. While these other people may have found certain things, a protein diet on its own is not a problem. You will not find, there's a whole lot of other more studies that they actually did not had a negative result like theirs compared to the positive that these others, and one wasn't even a rat study, it was actually a rabbit, and rabbits are very different. They're not even omnivores, so I'll just ignore the bunny thing completely. But even the other ones had minor in many regards. I've looked at them, and you can actually, because you'll find it, I'll be linking all these studies, so you'll be able to go and find them for yourself. The reality is, we don't find anything, and that's the important thing of the take-home message. These guys really did proper studies, really well controlled, and if there was anything to be shown, and also massive, we're talking about 70+%. Nobody would eat a 70+% protein diet. Just would be very hard to, with real food, it would be extremely hard to ever consume that amount. So, but even if you're, let's say, somehow found a way to consume that amount, you for 30 years, you would still not have any damage. So, let alone the amounts that we do consume, which are the more normal range of, around the 30-odd%, maybe 35% some, it's a non-issue. The only, and most of the other studies that a lot of these studies are all on super high protein when they're comparing it. This is not what normal people would eat as a percentage. The difference is these guys did a super high protein diet, but they made sure that all the micronutrients were covered. Really important. So there was enough cofactors to basically support all the enzymatic pathways to deal with all this sort of stuff. Really important. Because we know that micronutrient deficiencies, whether it's zinc, iron, or whatever, cause disease. We know that now. So we know that micronutrient diseases are the biggest driver of disease, deficiencies in micronutrients. It's, as I said, the foundation of anything. So it doesn't surprise me that all the studies that did find probably were micronutrient deficient, as they've pointed out on the studies that they knew about. The others where those study groups had not provided the full information of how they did their studies, it's really hard to comment, as they pointed out, which is the reality. I mean, if you don't know exactly how the study was conducted, the exact food that was given and stuff like that, you can only speculate, as they pointed out. But doing proper studies with, where you've got the data and the information about exactly what they were consuming in terms of the micronutrient profile, you don't see it. And that's the take-home message, the most important. The only constant effect of these diets, if we accept the interesting but obscure influence of high protein on the rate of protein excretion, was a slight hypertrophy or growth of the kidney, a decrease in the weight of the liver, and a failure to store fat when the bulk of the food consisted of casein. So basically, what they're saying here is your kidneys become slightly larger to be able to deal with the extra uric acid and stuff like that, and protein that you need to deal with excretion. Your liver becomes shrinks down a bit, probably because you're using more free fatty acids than glucose. And, the failure to store fat is basically, well, you're not getting fat. You basically are it's nearly impossible to actually put on fat. So, if you're consuming a casein diet. So, and remember, when we talk about casein and whey and stuff like that, it does have all the essential fatty acids, which is good. So we know that, it's a surrogate marker for other proteins that are complete proteins, which are animal proteins really, because plant proteins are not complete proteins. So we know with complete proteins, things are good. Anyway, conclusions. 1, rats, which lived on 1/3 of their lifetime on a diet which contained 70% of protein, grew nearly to the same length as the controls, but had a lower body weight as a consequence of almost complete absence of fat. So they were basically lean buggers. That's what they're actually saying. There was an increase in the weight of the kidney and a decrease in the weight of the liver. I've explained that. No pathological changes were found in the urine or in the kidneys of the rats, which had lived to 70% on 70% protein, or on a diet which contained 1% of cysteine. And all the actual references for the other studies are just below here that he was referring to. So you can Google them if you want to find out and read them. And that's pretty much it, guys. That's pretty comprehensive. When you get to those sort of levels of 70%, we're talking about an order of magnitude which is massive. There is no way that it is practically easy for a human to consume that level of protein from normal food. Maybe from supplemental sources you could probably get to those levels, but you're not going to get from normal food. So that's the important message there. So, but even if you were to somehow achieve that feat of of 70+% of protein intake for 30, and you did that for 30 years, you would still not have problems with your kidneys And that's the important thing. So all the other stuff is associational. It's not experimental. It's all associational, or people with end-stage renal problems who are diabetics, and we know what causes that. Don't we, salad boy? Yes, it's that honey, that glycating honey. Yes, that sort of shit. So, yes. So basically, when we look at the literature and we look at people who really have kidney issues, it's people on standard diets. And we know that what they comprise of: seed oils, toxic seed oils, refined sugars, and refined carbohydrates. That is what is driving kidney disease. Because until we basically switch to the low fat sort of diet, we didn't have this rate of kidney disease. Now dialysis is all over the place. You know, they dialysis areas that provide dialysis service are mushrooming all over the place. And now that everybody's getting on a kibble diet, it's going to be worse. I mean, even one of the guys at work, he's a vegetarian and he's on a dialysis machine. So, you know, let alone if you go 100% plant-based and, you know, people are just going to wreck themselves. There's going to be a horrendous amount of kidney disease in the future due to these species inappropriate diets. Anyway, try and spread the message, get this around. Please post it around, share it on your social media sites so people can actually see and demystify, you know, what protein does and what it doesn't do. And so people can understand that protein is not the scary thing that they've been told to avoid. And it's really important if you want to maintain good musculoskeletal structure going into old age. Anyway, thanks for listening to this take on protein. Anyway, see yous.